Okay. For design of singly reinforced concrete beam, NSCP 2015, Part 2. So, second problem. So, in this problem, we have a 4.5 simply supported rectangular concrete beam and has a width of 300 mm. Effective depth is 530 mm and total depth of 600 mm. The beam is to be reinforced with 20 mm diameter bars. The concrete strength Fc prime is 21 megapascal and the steel yield strength is Fy 275 megapascal. The beam carries a precast 100 mm thick concrete slab that is 4 mm wide. The unit weight of concrete is 24 kilonewton per cubic meter. Floor live load is 2.4 kilonewton kilopascal. So, use fee 0.9 or yung pabilog yun. 2015, NSCP 2015. So, what does it mean na fee 0.9? So, syempre dapat tension controlled. Diba? Yun yung sabihin nun. So, first is we calculate the factored moment. That's the first problem. Second is determine the governing steel ratio. Third is determine the minimum number of 20 mm diameter bars required as tension reinforcement. Okay? So, drawing muna natin para mas dali natin maintindihan. So, we have a beam daw. Diba? Clear natin dito. O baka sobrang laki. We have a beam which is 600 mm. Ito, 600. Mamaya natin lagyan ng dimension. Ganyan na lang, pantay din. Medyo awkward. Pero ayaw na. Ayan. Para lang may visualize lang. Though medyo paleng. Diba? So, we have a beam. Oh, ayoko, nainis ako. Palitan natin to. Bawasan natin. Ito. So, we have yan, para mas tama to. Anyway, hindi tayo sa architecture. Okay na yan. So, we have 600 mm total depth of the beam. Then, from effective depth, ano effective depth? Sa centroid ng mga bakal, di ba? You have 530. Sabi ba ng 530? Ayan, 530. Then, ang length ng beam mo is 4.5, diba? So, that is 4.5 meter. Diba? Ang width ng precast slab mo is 4 meter. Ayan. Yan. Okay? So first is calculate the factored moment. Paano ba to? First, bigay mo na ako ng background. Kasi ito, binigay na dito, yung bubuhatin niya ng slab. Pero in real life kasi hindi naman laging ganon. Diba? Paano natin malalaman kung ano yung maililipat sa kanya? For example, we have a quick quick lesson lang, background sa theory structure to dapat. Ano lang to, for example lang, for example, we have 6 meters, eto 2 meters, 2 meters, 2 meters. You have to divide yung length sa width. So, for example, dito, 2/6, so that is, or 6/2, that is 3. So, that is greater than 2. If yung ratio ng longer side sa shorter side is less than 2, ang mangyayari doon, is greater than 2, mangyayari doon, magiging one-way siya. Anong sabihin ng one-way? Hatiin niya sa gitna. Yung kalahati niya, mapupunta rito. Okay, eto, kalahati nito, mapupunta dito. And because greater than 2 yung ratio ng long over short. Diba? So, ibig sabihin, yung kalahati daw pala ng load mo dito, ang bubuhat itong beam. Kalahati na kabilang side mo, ang bubuhat yung left side. Okay? Now, paano, for example, ito, baguhin ko itong isa. Ang length nito is 4 meter. Hindi natin block. Sige. Ano mangyayari dyan? 6/4 is less than 2. So, magiging two-way siya. Ano yung sabihin ng two-way? Ganito na ang distribution ng load niya. Gagawa ka dito ng 45 degrees. Dito rin 45 degrees. So, ayan, triangle yan. Sa gitna. So, mahati siya ngayon sa ganito. Okay? Etong kabilang side, ang dadali niya is trapezoidal. Ayan, trapezoidal na siya. Itong kabila din, trapezoidal. Ayan. Pero, eto, ba't may triangular? Yung triangular part, dadali na yan ng ano? Nung other beam sa taas. Okay? So, for example, this is AB. We want to get the beam AB. Ito, section niya. Beam AB. So, ang dadalhin niya is yung yellow ni one-way slab. Diba? Dadalhin niya yan. Quick review lang to, Tapos, dadalhin din niya yun sa two-way slab. Diba? Dadalhin din yan. So, yan. Okay? So, ganyan, pag one-way sa two-way. Diba? Ang two-way, mangyayari lang siya pag yung ratio ng long saka short is less than or equal to 2. Diba? Pag greater than 2 na siya, one-way na siya. Palatandaan, one-way, parang wala namang isang way lang dyan. Tingnan mo dito, isang way lang siya, isang line lang yung direction ng load. Dito kasi may papunta rito, tapos may papunta sa taas. Okay? So this one way, this is two way. Pag one way, ano mangyayari? Pag one way, mahati lang siya sa gitna. Pag two-way, magkakaroon ng trapezoidal at rectangular load. Okay? So, makakakuha ka dito ng reaction. Yung reaction na yan, yung ilalagay mo dito na pointed load. Diba? Okay? So, that's quick background lang. Quick review. So, usually naman, hindi naman ganyan Ang tanong, just in case lang na ibigay, di alam niya na. Sa problem kasi natin dito ngayon is binigay na yung slab, di ba? Okay. So, back to the problem. First question is calculate the factored moment. So, what is the factored moment? That is MU, the required design strength. That is MU. No. A factored moment is yung the MU. Ano yung MU niya? Ano yung dapat niyang dalhin? Diba? Ano yung dapat strength niya? Factored moment is just the required design flexural moment. That is the question in the first problem, di ba? For previous video. Ano daw yung dapat niyang dalhin na moment? Ano yung design flexural moment niya para pag doon mo siya dinesign, safe yung structure natin. Diba? So that's the first question. So how do we solve that? Okay. Solution. First is we get the uniform load, diba? So from dead load muna tayo. So from dead load, we have weight of the beam, diba? Kasi ang dead load sabihin yung weight of the structure, diba? Weight of the beam, uniform load ng beam. Ano ba formula nun? So you have, ganito lang yan lagi. Gamma of concrete multiplied the area of concrete. Diba? Gamma multiplied the area, unit weight multiplied to the area ng concrete, makukuha mo yung uniform load. Diba? So, gamma ng concrete, sinabi, 24 kilonewton per meter cube. So you have 24 kilonewton per meter cube. Multiply to the area ng concrete. Ano ba area ng concrete natin? Ng beam. Ano area ng beam? You have 300, di ba? Ito, 300 to. So, that is 0.3. 0.3 times 0.6. Diba? So, you'll get 4.33 kilonewton per meter. Okay? So, ano ba yan? Pakita natin kung ano yan. Ba't natin ginagawa yung uniform load muna? Okay? Cross-section to area ng cross-section. Area ng concrete beam ng cross-section. Unit weight times the area of the cross-section of the beam. Next, is yung weight ng slab. Ito yung beam to Ito, slab. Diba? So, weight ng slab. So, that is concrete tapos area, cross-section area lang ulit. So, that is 24 kilonewton per meter cube. Diba? Ito kasi meter, under meter. Kaya nagiging meter na lang. Diba? Multiply to the cross-section of the beam. The slab. Ano ba cross-section niya? Ang thickness ng slab is 0.1 kasi 100 mm daw Precast lang siya. So, sabihin, pinatong lang. Okay? So, you have 0.1. Ngayon, anong gagamitin natin na length? 4.5 o 4? Gusto natin gawin na magkaroon ng uniform load here. Under the beam. Diba? Along the beam. So, dapat, ang i-multiply natin, etong 4. Kasi pag nakuha natin yung unit load na to, yung uniform load na yan, along the beam, makukuha natin yung maximum moment. Diba? So, in order to get that uniform load, we have to multiply it to the cross-section. Ito yung cross-section, no? So, you have 0.1 times 0.4 times 4.0. So, you'll have 9.6. Diba? You have 9.6. So, 9.6 kilonewton per meter. So, pag add natin yung total dead load, that would be 9.6 plus 4.33. So, that would be 13.93. Ba? 13.93 kilonewton per meter. Okay. So, ano yan? Sige, lagyan natin dito. Sa dead load, 13.93. Now, next, lagay naman natin ngayon yung sa live load. Diba? Ano ba yung sa live load natin? Sa live load natin, ang sinabi lang dito is 2.4 kilopascal. So, ibig sabihin, kilopascal is in terms of kilonewton over meter squared. So, ano na lang kailangan natin multiply? Diba? So, sa live load natin, or uniform load ng live load is just the pressure multiplied to the tributary width. Ang width natin dito is, di ba, 2.4 kilopascal or kilonewton per meter squared multiply to 4. 4 na lang mo multiply, hindi na cross-section na kasi kilopascal na siya, hindi siya in terms of unit weight, di ba? Hindi siya cubic meter yung denominator. It's just meter squared. So you only need to multiply the 4 para maging uniform load siya perpendicular to that. Di ba? 4 perpendicular to that is the uniform load ng beam. So we'll have 9.6. Okay. So you have 9.6 live load. Tama ba? Tama. 9.6 live load. Di ba? Nabobo. Okay. So, we'll have uniform load ng dead load and live load, di ba? Ang live load natin is 9.6 kilonewton per meter. Di ba? So, paano na yan? Meron na tayong uniform load. We need to get the maximum moment. Di ba? Maximum moment ng dead load, live load. Pero, gawin mo natin, yung uniform load natin, pag-isayin natin. Paano yan? Ang uniform load natin, total natin dyan, gawin natin design, diba? It's just 1.2 dead load plus 1.6 live load. So, we'll have 1.2 ng 13.93 plus 1.6 ng live load which is 9.6. Ano makukuha natin? Where's my calculate? One point two ng 13.93 plus 1.6 ng 9.6. So you have 32.08 kilonewton per meter. So ito na ngayon yung required dyan sa part na yan, di ba? Pero ang tinatanong moment, hindi uniform load hindi uniform lang tinatanong. What is the moment? Ano yung moment na kailangan ko? Diba? What is MU? Since factored na yan, 1.2 na may factored na yung diba? Factored uniform load na yan eh. So direkta, makukuha mo na ngayon yung MU. Diba? What is MU? A maximum moment ng uniform load is W L squared all over 8. Back to your theory of structure ulit. Diba? Yan, that's the formula. So, plug in that values to this formula, we have 32.08. Ang length natin, anong length? That is length of the uniform load. So, that is 4.5. Baka may magumamit ng 4. 4.5 tayo ngayon Length na. Okay? So, 4.5 squared all over 8. So, that's 32 times 4.5 squared divided by 8. So, you'll have 81.2 kilonewton meter. So, this is the answer for the first problem. Okay? That is the factored moment. Okay, proceed to the next problem or next question. Determine the governing steel ratio. following the NSCP 2015. Paano ba natin kukunin mga ratio, yung mga steel ratio, diba? Kunin mo natin yung actual niya. Kunin mo natin yung steel ratio ng beam ng pinaka ano natin. So, meron tayong MU. We now solve the Rn, diba? Anong Rn? MU over phi BD squared. Ang MU mo is 81.2 times 10 raised to 6. Yung rho natin, let's use 0.9 para tension control daw, di ba? Kasi gusto niya gawing tension control. So, ang B natin is 300. Ang D is 530, hindi 600 530 squared. So, using that, you'll have rho or Rn na 1.07. Diba? Then, after that, you'll solve the rho. Ang rho is 0.85 Fc prime over Fy multiplied by 1 minus square root of 1 minus 2 Rn over 0.85 Fc prime. Diba? Plug mo yan. Ito, store mo sa A or ito, plug mo dito. Ang Fc prime natin is, ano ba Fc prime natin dito? We have 28 megapascal. Fy is 275. Diba? So, using that, you'll get what? 0.00402. Yan. So now, you compare. Yan ba yung gagamitin natin? Right? Is that the governing steel ratio? You check. Saan mo i-check? Check mo kung lumagpas ba siya ng rho max. Check mo kung bumaba ba siya ng rho minimum. But in this case, ano yung key point dito? Para malaman mo kung saan mo i-check? You have to check if ilan yung zero before the number. Ilan yung zero after the decimal? Dalawa. So most probably, ang critical lang dyan is yung rho minimum. So you have to check the rho minimum. Diba? In our previous video, we have 2 rho minimum. Ano ang gagamitin mo sa dalawa? Since ang Fc prime natin is 21, you have less than 31.36. So, the rho minimum is 1.4 over Fy. Ilang yun? Usually, yun naman ginagamit. Diba? So, check natin yung rho minimum. Ano ang rho minimum? 1.4 over Fy. Ang Fy is 275. Diba? So, ano ang magiging rho minimum? That is 0.005 0509. Which is greater that? Which is greater? Therefore, rho is less than rho min. Pwede ba yun? Hindi pwede. Hindi mo pwede gamitin yung less than rho min. So, ang gagamitin mo na ngayon, yung rho minimum natin. Which is this one. Ito ngayon yung mag-govern. Yan yung mag-govern. Okay? So, yun yung gagamitin mo ngayon sa ES. So, that's the second question. Last question. Determine the minimum number of 20 mm diameter bars required as tension reinforcement. Diba? So, as tension reinforcement. So, we have AS. Kunin mo natin AS. Which is rho BD. In this case, rho minimum ang gagamitin natin. Diba? Kasi hindi mo pwedeng gamitin yung rho mo. Kasi mababa siya sa rho minimum. Eh, di ba ngayon na yung limit? So, yun ang dapat mong gamitin. Yung rho minimum. Eh, sir, paano pag lumagpas naman sa rho max? O, hindi mo pwedeng gamitin yun. Rho max na ngayon, di ba? So, that is doubly reinforced. So, sa minimum, yan yung minimum. Hindi ka pwedeng bumaba naman dyan. Dapat nasa pagitan lang ng dalawa. Okay? Ang B natin is 300. Ang D is 530. So, ang AS natin is 0.005. 09 times 300 times 530. That is 809.31. Now, we may not check na kaagad kung nag-yield ba siya or kung tension control ba siya or not. Why? Kasi sabi sa problem, use fee 0.9. Okay? Pero, if hindi naman sinabi ganyan, you have to check. Tama ba yung assumption mo na fee is 0.9? How do you check if yung tama yung assumption mo? Using C is equal to T. Diba? In our previous video, using C is equal to T, you can solve the A and C. Then using that C, makukuha mo na ngayon yung Fy, yung Fs. Then malalaman mo na siya na tension control siya or nag-yield ba siya or not. Diba? But in this case, hindi ko na siya check. Okay? I'll skip this process. Process 6 and 7. Why? Kasi nga, alam ko na mag-yield siya. Sinabi na sa problem eh. Pero kung hindi nagtitiwala sa problem, you check it on your own. Okay? So, now, next natin is dami na kaagad tayo ng bakal. N is just total over ng individual bakal. Diba? Total area over individual area ng bakal, makukuha mo yung number ng bakal. Diba? Parang algebra, basic algebra. So, AS is 809.31 all over pi over 4 20 mm. Tama ba? 20 mm ba yung tanong? 20 mm. So, that is 20 mm. So, you'll have 809.31 over 809.31 divided by, so you'll have 2.57. So what is the answer? Use 3 20 mm diameter bar. Okay, so that's the answer. 3. Sir, paano kung lumabas is 1.2? Dati, ang gagamitin mo is 2. Diba? Ito ang gagamitin mo. Kasi, lagi kang pataas. Dahil bakal to eh. Pag ginawa mo, ni-round down mo yon, problema no, magkukulang yung design moment mo. Okay? Design strength mo, magkukulang. So, laging pataas. Sir, paano pag 0.5? Ako nga, ang lumabas dito, 0.5. Kung lumabas, 0.5. 0.4. Para crucial. Ano gamitin ko? Gamitin mo dyan, 2. Okay? Pati hindi 1. Kala ko pa round up. Hindi ka pwedeng gumamit ng 1 na rebar lang. Dapat laging 2. Yun ang minimum mo. Bakit? Imagine, kung ito yung beam mo. Kung isa lang rebar mo dyan, saan mo isasabit yung stirrup? Di ba stirrup mo pa ganun? So, dapat, ang minimum daw is 2. Para may pag-aayusan yung stirrup. Okay? So, ito keynote na rin to Okay, so dito, in this problem, 3 yan. Okay? So, that's all for this video and I hope you learned something and see you to the next chapter or next video. Bye.